Good morning. Today we're going to talk about 6-1 operations on functions. Let's get started. So here's some definitions of the operations. This is a new style or notation that you might see. Don't think that it's anything more complicated than what you already know how to do. For addition, we'll see that this is f plus g of x. And really, if you want to translate it, all that really means is take f of x, take g of x, and add them together. Same thing goes for subtraction. F minus g of x really just means f of x minus g of x. And again, f times g of x means f of x times g of x. So let's try these two examples here. So given f of x is s squared minus 4, g of x is 2x plus 1, find these. F plus g of x. That means I'm going to take f of x, which is x squared minus 4, and add it to g of x, which is 2x plus 1. What's really nice about this problem is all I have to do is really combine like terms. So the x squared, I have nothing to combine it with. Then the 2x, and then I can combine this negative 4 and this one together to get minus 3. So that's how I would do that operation. For the next one, we're going to do f minus g of x. So I'm going to have x squared minus 4 minus g of x, which is 2x plus 1. What I want to recall is that negative, I kind of need to distribute that negative out. So minus 2x minus 1. And then from there, I just simply combine like terms again. So I'll have x squared minus 2x minus 5. Okay. Let's practice this one, which is f times g of x, so just multiplication. So I'm going to take f of x, and notice the problem has changed. I'm going to take x squared plus 7x plus 12 and multiply it by 3x minus 4. So here I'm going to distribute x squared. So that would give me 3x to the third minus 4x squared. Then I'm going to distribute the 7x. So plus 21x squared minus 28x. And finally, I'm going to distribute the 12. So plus 36x minus 48. All right, I just lined it up this way just so my like terms would already be lined up and I wouldn't have to figure it out too much. So I have 3x to the third, 21 minus 4, 20, 19, 18, 17, 17x squared, 36 minus 28. Okay, so I have my final answer, which I combined these like terms and then I finished it up. So the next thing that we're going to talk about, which I think this is something you haven't seen yet, is called a composition of functions. So this is what happens when I take one function and basically plug it into another. So it's written this way. This does not say fog or goth. It says f of g of x. F of g of x, another way you might see it written is this way, f of g of x, and g of f of x. Yes, these are two different things. This first one is telling me to plug the g function into the f function. Plug g into f. And this one is telling me to plug f into g. Plug the f function into the g function. So let's see what that looks like. First, we're going to have these ordered pairs. For each pair of functions, find f of g of x, g of f of x, if they exist. State the domain and range for each composition. So how this works, we're going to find f of g of x first. We're going to find this first. So f of g of x. So notice what happened. I'm going to plug the g function into the f function. And I'm going to do that basically for each of these numbers. So I'm going to first start out with looking at these x values of g. And I'm going to take f of g of 8 and figure out what that happens to be. To figure that out, let's start out by finding what is g of 8. It's 15. So I replaced this where it says g of 8, I replaced it with 15. But now notice what my function says. It says to find f of 15. So I go to my f function, and if I were to plug in 15, that output value would be 11. So it's basically input, output, input, output. Let's try the next number, which is 5. F of g of 5. First, figure out what is g of 5. G of 5 is 1. And then I have to find f of 1, which is 8. Next one, I'm going to do f of g of 10. So I'm going to start out by finding g of 10. G of 10 is 14. So that means I need to find f of 14, which is 9. Finally, we're going to do f of g of 9. So start out by finding g of 9. So I'm working this inside of the parentheses first. G of 9 gives me 0. So I have to find f of 0, which is 13. Okay. Let's go ahead now and work on the other part of the problem, which is g of f of x. So g of f of x. So what I'm going to do is start out by finding the f of x function right here and plug in the first value, g of f of 1. So I'm going to start by figuring out what is f of 1. F of 1 is 8. So then I had to figure out g of 8, which is 15. So input, output, input, output. I'm going to next find g of f of 0. So plug in f of 0, I'd get 13. And then g of 13, I don't actually see an answer there. Let's do g of f of 15. So f of 15 would give me 11. So working this inside of the parentheses would give me g of 11. But what is g of 11? I don't actually see anything. I don't see a part where the x value of g is 11. And then finally, g of f of 14. F of 14 would give me 9. So I'm looking for g of 9, which is 0. All right, so now to write the domain and range for this, the domain is going to be those initial inputs. So these values here, whenever I write domain, I always just put it in order from smallest to largest. 9, 10. This is discrete, so we're just going to list all the points. And then the range for this is going to be the outputs. So again, I'm just going to put them in smallest letter, just 8, 9, 11, 13. All right, similar to over here, my domain would be these input values, but notice on this one and this one, I don't have an output, so we can't count those. So I'm just going to count the ones that are complete. So I'm going to count for my domain 1 and 14. And for my range, I'll count 15 and 0. So I'll put it in order 0 and 15. Okay. Here's another situation you might encounter. For each pair of functions, so we have two functions, f and g, find f of g of x and g of f of x. So let's start. F of g of x. G of x. What that means is I'm going to take this g function and plug it into the f function. So where I see that a, I'm going to replace it with 4a. So sometimes how I do this is I like to write down the outside function, which is 2a minus 5, and then kind of make an arrow here to note that I'm about to replace that a with 4a. So then that would give me 8a minus 5. But let's notice what g of f of x looks like. G of f of x would be me taking this f function and plugging it in here into the g function. So I'm going to write down the g function, and where I see a, I'm going to replace it with 2a minus 5. And I'm going to just distribute. So that's going to give me 8a minus 20. Both of these scenarios are linear, so my domain and range would just still be all real numbers. All right, let's try another one. Go ahead and pause the video, and I want you to try to do this one on your own. All right, so check it out, see if you got the same answer I did. I wrote down the f function, and within it, I replaced it with the g function. So here, negative x minus 4 squared, I wrote it twice to square it and worked it out. I distributed the negative here, and then added 2 and combined like terms. And then on this part, I wrote down the g function, and then I distributed this negative and combined like terms. As far as the domain and range, I noticed that both of these are quadratic, so I know for sure that my domain is going to be all real numbers. To find my range, I have to find that value of the minimum or maximum. So what I'm going to do first, just kind of a little side lesson here, something you learned but may have forgotten. We had to do negative b over 2a, and then plug it in, f of negative b over 2a, to figure out that the value for my range. So negative b over 2a, on this first one, I'm going to do negative 9 over 2, so negative 4.5. And then I have to plug that value in to this equation to figure out the range. Okay. All right, I plugged that in, and just a rough sketch of what this quadratic would look like. My lowest value would be at 1.75. 1.75, something like that. So this range would be y is greater than or equal to 1.75. I'm going to go ahead and do the same process, negative b over 2a, and plug it in to figure out the range on the blue bus. All right, I noticed that this range is going to be upside down because a is negative, so I put y is less than or equal to negative 5.75. All right, enjoy your day.